Inverse functions. Okay. So what do inverse functions do? We covered this a long time ago. What do they do? You flip them. You flip the what and the what?
X and the Y.
X and the Y. So the X and Y switch locations. There we go. X and Y. Okay? So, when it comes to sine and cosine, which is what we're going to cover in chapter 7, what does the inverse of them look like? Good. It has that -1 added. So today, you're going to have sine -1, cosine -1, tan -1 is what you're going to be dealing with. Not sure what's happening. Oh, they do. I think mine is one of the few ones that still works, but I kept the cords right here. So in order to come over here and write, I trip over the cord. All right. So when I taught in college, the college bought one, and it was like a big deal. And now, like, people aren't using them anymore. Mm-hmm. Yeah, like me. I use it as a projector screen. All right. So what do the numbers mean? So I think what I meant by this is, for example, if you have the point 0,1, what happens to that point if you find the inverse? It's 1, 0. Okay? So, I'm sorry, I can't handle this anymore. All right. So it says, find the exact value of sine inverse of -1, or +1, sorry. So, while you can do this on your calculator, my guess is on the calc test, they're going to have you do it without. So I'm going to have you do it without, okay? So what this is asking is, if you have the graph of sine looks like this, correct? What it's asking is, where does the graph hit 1? So where does the graph of sine hit the number 1? What is the x value for that? Yeah, this would be pi over 2, right? Because right here would be pi. Okay? So if you graph it, you guys see how I graph sine? I said, okay, I'm looking where sine is 1. Sine is 1 at pi over 2. So pi over 2 would be your answer for this. Or 90 degrees. Okay? So the next one says, find the exact value of cosine of -1 of -square root of 2 over 2. So if you see that square root of 2 over 2, what triangle does that connect with? Just remember? It's one of those, but which one is it? 45, okay? 45 is the one with square root of 2 in it, okay? If it's 1/2 or square root of 3 over 2, that's the 30, 60, 90, okay? So if it has square root of 2, it's the 45, 45, 90, okay? If it has square root of 3 over 2 or 1/2, those are the 30, 60, 90, okay? And then for whole numbers, like on the previous one, I typically draw the graph of sine, cosine, or tangent, okay? So, where is cosine of -1 negative square root of 2 over 2? Okay, Is cosine negative in the first quadrant? No. Where is cosine negative? Cosine is negative in 2 and 3. Good. So cosine is negative here. And they just want like the first time that it's negative. Okay, so we're just going to go in the second quadrant. Okay, we know it's a 45-degree angle in the second quadrant. So how many degrees is that going to be? It's 135 degrees, which is also 3 pi over 4. Okay. So remember, this is half pi, this is all of pi. Right in between those two is 3/4 of pi. Okay? So sine inverse of negative 1/2. Which triangle does that deal with? 30, 60, 90. Where is sine negative? 3 and 4. Okay. So remember, you want it where it's first negative. So it's going to be down here in 4. If sine is negative 1/2, it means this is negative 1 and this is 2, right? So how many degrees is this? Well, I have these drawn wrong, don't I? It should be like this, right? It's a 30. So it should be 210 degrees, right? And then 210, what I would do is I would do 210 times pi over 180. Okay? Which is 7 pi over 6. Okay. So with a 30, 60, 90, sine, this would be negative 1, this would be 2, because sine is opposite over hypotenuse, right? Okay? I drew my original triangle wrong. I drew it as a 60 in that. I should have drawn it so that a 30 was here. Okay, this is 180, you had 30, so that's 210. Okay, which if you want the pi version, you multiply it by pi over 180. Each of these are divisible by 30. 210 divided by 30 is 7. 180 divided by 30 is 6. Okay, remember your calculator would reduce that for you. Do you guys remember how to reduce them on your calculators? Okay, remember it's 210 divided by 180. And then math, arrow fraction. Okay? So this next one, it wants where cosine is 0. So cosine is 0. Cosine looks like this, right? So I remember I said for like 1s and 0s, use the graph, right? So 1s and 0s use the graph. So pi would be here. So where does it first hit 0? Pi over 2. Pi over 2 is right there. It also hits it at 3 pi over 2, correct? Okay. This, I mean, so long we haven't covered this for a month. Okay. Normal cosine, it looks like this. So the inverse is telling us we're looking where y is 0. So like this one, we're looking for where your y is the negative 1/2. It's easier to see when you have the graph of them. This one, we're looking for where y is 1. Technically on this one, we're looking for where y is negative square root of 2 over 2, which negative square root of 2 over 2 is like negative 0.75-ish. And so you're looking for where the graph of cosine is approximately negative 0.75-ish, would be right about here. But it's hard to figure these numbers out. It's easier on these graphs than on this. Yeah. So once I got 210, to change degrees to radians, I multiply by pi over 180. and then I simplified. Each of these are divisible by 30. 210 divided by 30 is 7. 180 divided by 30 is 6. So it'd be 7 pi over 6. Okay? So anytime on these other ones, I knew them. But like this one, you would do 135 pi over 180. And then when you simplify, each of these are divisible by 45. So 135 divided by 45 is 3. 180 divided by 45 is 4. The previous one, we found pi over 2, which equals 90 degrees. 90 times pi over 180 is 1/2 pi, which is pi over 2. So every time you would just do that. Some of them you might know by heart. Okay, like pi you would know by heart. Some of them you might not. Yeah. You're always looking for the x value which goes with this y if it's inverse. Yes. So if you wanted sine of 1, well, for example, if you wanted cosine of 0, cosine is 0 means your x is 0, so your answer would be 1. Cosine inverse equals 0, it means your y is 0. Well, y is 0 here. That helps? Good question, Seth. All right. Can we try tan inverse of 1? Okay, so tan inverse at 1. If you have the graph of tan, it looks like this. Okay. And remember, this is pi over 4. This is negative pi over 4. That's just the set points of it. Okay? So when it hits 1, your answer is pi over 4. Which is 45 degrees. I'm not sure which version they want you to have today, so let's just do both. Get some practice at changing between degrees and radians. What if they had wanted tan inverse of negative 1? Be negative pi over 4. Because it's asking, where is your y value? 1. Yep, pi over 2. Yep. Yep. So you're looking for where your y is 1 on your tan graph. So y equal 1 on your tan graph is at pi over 4. If this had tan inverse of negative 1, y is negative 1 at negative pi over 4. This is at 2 pi. So sine and cosine is 2 pi, tan is pi. Or do you want the graph? This one? So this is 2 pi. Okay? All right. So tan inverse of negative square root of 3. So I said negative square root of 3 is the 30, 60, 90, right? Square root of 2 is the pi over 4. So square root of 3 is the 30, 60, 90. Where is tan first negative? The second quadrant, right? Okay. So the second quadrant is where it's first negative. Okay. So it says this is negative square root of 3, and then this must be 1, because remember, it's opposite over adjacent. Negative square root of 3 over 1. So how many degrees is this? 60. Across from 1 is the 30. 60. Yep. So this is 60. 180 minus 60 means this angle is at... Well, this would actually be negative. This would be positive. But then together it makes the negative. Thanks for pointing that out, Connor. So then it'd be 120. And then we would do 120 times pi over 180. Each of those are divisible by 60, correct? because this is 60. And 180 minus 60 is 120. Okay? You go from 180. You always go from this baseline. Okay? And then each of these are divisible by 60. 120 divided by 60 is 2. 180 divided by 60 is 3. So 2 pi over 3 would be the radian version. How do we feel about those? We're good? Okay, then it says find an approximate value. Are either of these ones that we know? They are not, correct? We don't know them. So what do you think you have to do for those? Plug them into in what mode does it have to be in? Radian mode, because they're not degrees, right? So for these, you would plug them into your calculator in radian mode. You would just hit second, sine inverse 1/3, and that'd be your answer. Yes, yep. If I say find an approximate value, use your calculator. Well, it says approximate. Let's round to 3 decimal places. So what do you get when you round to 3 decimal places, sine of 1/3? Okay, if you did not get 0.340, that does sound accurate. It's because you're not in the right mode. So you have to hit the number or the button next to your second and change it to radian mode. Yep, you hit second sine to get sine inverse. Okay. It is second, and then the up arrow, it's right above the divide sign. So second button above the divide sign. So this is how we did it in geometry. The above stuff is kind of the pre-calc, the knowing those angles and those graphs version. What did you guys get for the second one? What did we get for this one? 0.393. And this one? All right. Any questions?